Namoe Tabi, a PhD candidate at the Regional Water and Environmental Sanitation Center. I'm studying water supply and treatment technologies at KNUST. As part of this study, I'm carrying out a research to determine the effect of artificial water channels on polyamide membranes and also to optimize these membranes to remove some groundwater contaminants such as fluoride, iron, manganese, and nitrates. Water is a basic necessity of life and hence a very essential natural resource. Lack of access to safe and affordable water, among other things, such as proper hygiene and sanitation, tends to negatively impact the health of billions of people around the world. It is no wonder that water has been captured among the Sustainable Development Goals, specifically Goal 6. Groundwater is believed to be the largest source of readily available fresh water for human needs. Small towns and communities most often depend on groundwater for their water needs. However, it is often not without contaminants such as heavy metals and excess ions, which tend to impact their health negatively. This project aims at developing a membrane filtration system to supply clean groundwater to small towns and communities. Polymeric membranes have been used for the production of drinking water for over 4 decades. Hence, they have been thoroughly researched and evolved over the years. Currently, research on these membranes is focused on increasing their flux, selectivity, as well as fouling control. Artificial water channels have been proposed and proven to help overcome the challenge of a trade-off between selectivity and flux of polymeric membranes. Artificial water channels are synthetic versions of aquaporins. Aquaporins are proteins that conduct water through lipid bilayers and reject ions with a very high efficiency. Some artificial water channels that have been synthesized and reported include carbon nanotube purines, imidazole quartets, and pilarine-based channels. The objectives of this study include to carry out a groundwater variability assessment of some boreholes in Ghana, to fabricate a thin film artificial water channel membrane, to determine the effects of artificial water channels on the fouling of polyamide membranes, to assess the ability of the membrane to remove fluoride, iron, manganese, and nitrates from groundwater, and to assess the ability of the membrane to be assembled into a Spiral 1 model to provide safe water to a small community. In all, this project is expected to result in the development of a thin film artificial water channel that can be used to provide safe groundwater for a small community.